All right, for today's lesson, we're going to talk about measurements of angles. This will be the introductory lesson in our trigonometry unit. So I know a lot of you found trig to be used quite often on the ACT test. So our objective is to find the measure of an angle in either degrees, which I think you're familiar with, or radians, and to find coterminal angles. So our definitions of revolutions, degrees, and radians. So in trigonometry, an angle often represents a rotation about a point. The angle theta, that's a Greek letter, kind of like a variable which stands for an angle measure, theta, is the result of rotating its initial ray to its terminal ray. So typically, the initial ray is like this, pointing straight to the east, and as we rotate this ray in this direction, that is a positive angle. If we rotate it down or clockwise, that would be a negative angle. So definition of a revolution would be just going all the way around, which would be 360 degrees. And as you're going to find out later in this lesson, that would be equal to 2 pi radians. Pi is about 3.14, so 2 times that, about 6.28 radians is one complete revolution. So one revolution is 360 degrees. It's also 2 pi radians, approximately 6.28. When we're talking about degrees, there are 360 degrees in a complete revolution. So you can see 1 degree is very small. And then each degree can be divided into 60 minutes, and by dividing each minute into 60 seconds, we can become very precise. So for example, this angle right here would be read 24 degrees, 42 minutes, and 50 seconds. Our third type of measurements can be radians. And the radian measure of an angle is the number of radius units in the length of the arc. And pi radians is 180 degrees. 1 radian is 180 divided by pi, which is approximately about 60 degrees. It's always good to think 1 full radian is about 60 degrees. All right, so converting between degrees and radians. To convert between degrees and radians, we're going to use the proportion d is to r as 180 is to pi. D is to r as 180 is to pi, because there are 180 degrees in pi radians. So to convert the following radians to degrees, if I use this proportion, I have 80 degrees. So I'm going to put 80 in for d. I'm going to try to find r. And so to do this, I'd cross multiply and divide. So it'd be 80 pi over 180. Now I could cancel, I could take a 10 out of these, I could reduce, and it would be 4 pi over 9. That would be what we call the exact value of that. If you type that in your calculator or you use, let's say, 3.14 for pi, that comes out to be about 1.4 radians. Remember, we said 60 degrees was about 1, so 80 degrees is about 1.4. So in the second example, we do the same thing. 230 is to r as 180 is to pi. And if we cross multiply and divide, 230 pi over 180. I could cancel those 10, so 23 pi over 18 would be the exact answer. And if I multiply that on my calculator, 23 pi over 18 is about 4. Approximately 4 radians is 230 degrees. 45 degrees. We'll talk about this one, how to do this quickly and mentally, but using the proportion 45 is to r as 180 is to pi, and crossing multiply, r would be 45 pi over 180. 45 goes into 180 4 times. So 45 degrees is exactly pi over 4. And pi divided by 4 is about 0.79, rounded to the nearest hundredth. Excuse me. All right, so converting to radians and degrees, you do the same thing. You use the same proportion, but you're going to plug in for r now. So converting 2 radians to degrees, we're going to go d is to 2, as 180 is to pi. If I cross multiply and divide, d would be 360 divided by pi. Now you learn that 1 radian is approximately 60 degrees. This is 2 radians. This is going to be exactly 114.6 degrees, rounded to the nearest tenth. 4.3, d is to 4.3 is 180 is to pi. Cross multiply, you're going to take 4.3 times 180 and divide by pi. And 4.3 radians would be about 246.4 degrees. 2 pi over 3 radians. Now they're giving you radians in an exact value, so we can go d is to 2 pi over 3, as 180 is to pi. If you cross multiply, you end up with 360 pi over 3. And then we're going to divide that by pi, which is going to cancel those. And 360 divided by 3 is 120. Okay, hopefully that makes sense because we said pi is 180 degrees. So 2/3 of 180 is 120. And we'll talk about how you do that exactly in the next slide here. So converting exactly, if we know pi radians is 180 degrees, then what would pi over 2 be? So what's half of pi? Granda, what do you got for that? 90 degrees, exactly. If pi is 180, then half of pi would be 90. And then 1/4 of a pi would be, Tyler? Exactly, 45 degrees. And dividing by 180, let's say pi divided by 3, that's 180 divided by 3, that'd be 60 degrees. Pi divided by 6, 180 divided by 6 is 30 degrees. These are kind of the main angles that we're going to use quite a bit in this particular unit. Okay? And then you can continue, like we just did 2 pi over 3. So I would just say, okay, pi over 3 is 180 divided by 3. That's 60. I've got 2 of them. That's 120. Let's say I've got 5 pi over 6. Well, I know that pi over 6 is 30. 5 30s would be 150 degrees. 5 pi over 2 would be like 5 90s, which would be 450 degrees. All right. Hope you're enjoying this video. Just a little check here on today's assignment up by your name. Please put D is to R as 180 is to pi. Write that proportion up there by your name. That just shows me that you did watch this video. Coterminal angles. These are 2 angles in standard position are called coterminal angles if they have the same terminal rays. So for any given angle, there are infinitely many coterminal angles. So for example, if I have an angle of, let's say, 30 degrees, but then I rotate this all the way around again, that would be like adding 360. And I could do that an infinite number of times to get angles that are in the exact same position. So 30, 390, 750. I'm just adding 360 each time. 1110. I could go backwards, negative 330. Those would all be coterminal angles to 30 degrees. So what are we doing? We would just take whatever the angle is. So let's say the angle's 80 degrees. If you want to get coterminal angles, you could just add and subtract 360 n, where n is any integer. So just keep adding 360 or keep subtracting 360. To get coterminal angles that are in radians. All right, so if you remember, we just added and subtracted 360. But 360 is, in radians, 2 pi. So if I want to know the coterminal angles to, let's say, pi over 4, I would just keep adding and subtracting 2 pi. But remember that to add fractions, you need to have a common denominator. So that 2 pi I could write as 8 pi over 4. And therefore my coterminal angles would be 9 pi over 4, 17 pi over 4, 25 pi over 4, and so on. So for coterminal angles, you simply, if it's in degrees, you want to just keep adding or subtracting 360. If in radians, just keep adding and subtracting 2 pi.